So we did up to question 2. And so of the tutorial sheet. So we're covering the whole sets, but the tutorial sheet covers the whole sets in a very nice way. So we'll be talking about so many things, but around the tutorial sheet. So the examples that will be the tutorial sheets, and then we'll be expanding a bit to tackle other concepts, because I understand that some of you are unable to attend lectures. So for that matter, we'll do that. So we went as far as question 4. Yeah, question 4. The whole question 4, I think. Did we? I haven't forgotten. Let me check. Send a PDF yesterday. Oh. I can't trace them. Okay, question 2B, question 3. So it's up to question 3. Okay. So go to question 4. So in question 4, we are talking about the properties of sets there. And the main property there is about the subsets. So an example, which we know is coming from the tutorial sheet. Tutorial sheet question 4. The question is, if A is a subset of B, simplify. So I want to check 1. If A is sitting in B, then what is going to be A intersection B? So we're talking of B being this set here. This is B. And then inside B, you have A. Then we say A intersection B. So intersection is what is found in both sets. So if you go to A and shade the whole A, you are sure that you have shaded the part of B that intersects with A, because A is everything in B, but A is, whatever is in A is sitting in B, because it's a subset of B. As you can see in the shading there, when you shade A, you have shaded whatever A contains that is in B. So it means that the intersection of A and B is going to be A. Second, A union B. So again, you have B, then you have A. Then you want to do A union B. So A union B, you have a set A plus what is in B. Now B includes A. So at the end of it, you just have the whole set B being shaded. So the union is going to be B. 3, A complement union B complement. So we go back, this is B, and inside is A. A complement, I'll shade, first I'll put this set in some universal for proper illustrations there. Then we'll shade A complement first. So A complement is everything outside A. This is A complement. Then B complement is everything outside B. This is B complement. This is B complement. So it's clear that the union, since union is addition, you add the complement of A plus the complement of B, but at the end of it, all you will have in your hands is the complement of A. So this is just reminding us that if A is a complement, if A is a subset of B, so we're saying if A is a subset of B, then B complement is a subset of A complement. That's what we are seeing here. Then for A complement intersection B complement. So because of this statement here, and the answer in 1, if B complement is a subset of A complement, then A complement intersection B complement is equal to B complement. It's clear in the shading that the two will intersect where we shaded the B complement there. So we'll have both sets there. Part 5, A complement union B. Now A complement union B, we have the set B, then we'll have the set A. Then A complement is everything outside A. Then union B. This is B. So as you can see, if you add the red lines plus the black lines, you end up having the whole universal set. So we'll call it E, where E is the universal set. So that's how you answer. You don't just say E and assume that someone will know you're talking about the universal set. You tell the marker to say, oh, where E is the universal set. If you use U, say where U is the universal set. And then 6, A intersection B complement. This is B, and this is A. So A intersection B complement. B complement is outside B. So you have this as B complement. So B complement intersection A. A is inside here. So you see that the two sets do not intersect, and so the solution is going to be M set. So unless we have questions, that's how you answer question 4.
Excuse me, sir.
Okay.
So
I didn't get where you explained on question 5 at the challenge with my gadget here in terms of network.
Okay. There's another question.
Yes, sir. I'm concerned about the same number 5. I'm concerned about how you come up with E. Because I'm seeing the union of A complement and B complement, you're coming up with an E. Where is the universal set?
So we're talking of B, and then A is sitting in B. Then you have A complement. A complement extends from A all the way up the universal. This in red here is A complement. Okay, this is A complement. Then then B. So A complement union. Union is like you're saying A complement plus B, except you don't add sets like that. So we add them using union. So whatever is in A complement plus whatever is in B, you put together. So you shade the whole B. So then your answer is the red lines plus B. So you see that everything that we are calling the universal has been shaded. That's why I said the solution is going to be the universal there. So the concept of union, it doesn't care much about the fact that A is sitting in B. When it comes back to shade to shade B, it will shade the whole B. Regardless of B having A inside, A will find itself shaded there. Okay. Then we'll talk about B disjoint sets. This is our question there. So I thought if A and B are disjoint sets, i.e. A intersection B is empty. When you hear that two sets are disjoint, it simply means the intersection of the two sets is empty. So A intersection B is empty. Then simplify. So let's see some more properties here. One, what will be A complement union B? Union B complement. A complement union B complement. So here you have a set of this type. This is A and this is B. This is A, this is B. So we shade A complement. A complement is outside A. This is A complement. We also shed B complement. B complement is outside B. Okay. So you end up seeing that, oh, then everything has been shaded in the universal. So the answer turns out to be A, where A is the universal. Then you go to 2, A complement intersection B. So again, you see, this is A and this is B. A complement intersection B. So if we borrow from this one, outside A, we have it in red. Where does the red lines intersect B? So it's the whole B. So solution is just going to be B. So that on the third one, we now talk about A intersection B complement. So the same thing will follow. The answer is going to be B, to be A. So you can shade it in the manner to shade it part 2. Then we have question 5. Shading and description. Part 1, which is A. Our job here is to use set notation to describe what has been shaded. So something has been shaded for us. You have a set A, then you have a set B, then you have a set C. Sitting in the universal. This is A, this is B, and this is C. Then we shade this part here. How do you interpret this shaded part here? How do you describe it? So to describe this, you first notice that this guy is actually in B intersection C. But certain part of B intersection C has not been touched. So then you say, oh, it's B intersection C intersection A. Have we touched A? We have not touched A. So then it is A complement. Because we have B intersection C was the target of this shading. But then A came in. So A was left out. Because A was left out, so we can say it's B intersection C minus A, which is the same as B intersection C intersection A complement. There's no harm in starting with A complement, intersection B, intersection C. Remember, intersection is associative. And we demonstrated that. So it doesn't matter if I have A intersection B, intersection C. This is the same as A intersection B, intersection C. So if I have intersection like that, then it won't matter how I put the solution there. Then part B, set sitting in the same.
Excuse me.
Hello.
on part A,
Yes.
you've said it's B intersection C intersection A complement. Now, why
Yes.
did you decide to say it's intersection? Because nothing of A has been touched, so we can't know if it's really intersection or it's union. Why did you decide to put intersection A complement instead
So
of O? Because we can even put B intersection C union A complement. I
if
don't
this
know why did
is
you choose intersection when
so
part of A nothing has been touched.
okay. So if we say, since this is B, this is C, this is A. If we say B intersection C, then we mean this whole part where B and C are intersecting. If we say union A complement, then we mean we must include these parts here, including the outside of A. So how do we restrict the solution to what has been shaded in the question? Since we have not touched A, then we are saying A complement, because A complement is the outside of A. Now, to avoid going outside here, then we use intersection, so that the part of A which is not in B intersection C should not be touched. That's why we have used intersection. If we use union, it will be hard for us to control and come back the restriction in the shading.
Okay, sir, I get it now.
All right. Okay, so this is to A, B, C. The shading starts inside here, and then it goes outside. Okay, so again, it's clear that A intersection B intersection C is shaded. So we start with it. The middle part there, A intersection B intersection C has been shaded. Plus the area outside A, B, C. So we'll say union, which is plus A union B union C complement. Is it okay? So the complement D has made our lives easy now. Okay, so you shade, since the intersection of everything there has been shaded, A intersection B intersection C, and then from there the only thing we are seeing shaded is outside A, B, C. So we'll say A union B union C. We now mean, so when I say A union B union C, we mean this. We mean this. This is A union B union C. But we have shaded the outside of it, so we have said complement. Okay. So after saying complement, we realize that something inside has been shaded, then we use union. to mean that thing. Then C, we have the sets here. A, B, C. This part is shaded. So obviously we know A has been shaded. So you start with the same A. So you say A, since it's A and some part of A haven't been shaded, so it will be A intersection. Then now we know that we have not touched any B, we have not touched any C. So then we'll say A intersection, what is outside B plus C. So B union C, as you can see, B union C is not touched. But then you have not gone outside these three sets. We are within A. So it will be A, what is common in A and outside of B union C. Then D, so clearly, B intersection C, B intersection C has been shaded, all of it. A intersection B has been shaded, all of it. So it seems the whole B, where B intersects A, is been shaded. Where B intersects C, is been shaded. So what does that mean? It means that we'll start with B. So we'll start with B and say intersection, because the other part of B has not been shaded. Then B has shared its shading with A and with C. So we'll say then A union C, everything in A plus in C, intersection what is in B. That's why I find that this part of B with A with C shaded, part of B with A shaded. So unless we have questions. Okay. So since there are no questions, we'll break off for 10 minutes. Then we are coming to do question 6 up to question 10. 6 up to question 10. And that's why this stereo sheet is difficult. So please don't miss that part. You can cool down for 10 minutes, then we join. So we are joining at 50.
So I'm asking for the first slide. Thank you.
Okay, so break off.